For 200 years, we called Damascus steel magic. Crusaders swore it could split a silk scarf falling upon its edge, but modern microscopes tell a different story. Inside this blade is nanotechnology, and the ancient smiths who made it had no idea. For centuries, the Damascus blade was the pinnacle of warfare. Its legendary sharpness and strength were matched only by the mesmerizing water-like patterns swirling across its surface. It was a weapon born in the Middle East, forged in secrecy, and brought back to Europe on the tips of Crusader swords and in their stories. European smiths, whose own steel was often brittle and crude by comparison, could only describe it with superstition. They recorded legends of bladesmiths with supernatural powers. They claimed the blades were quenched in dragon's blood or cooled in the urine of a redhead boy. These were attempts to explain the unexplainable, but the real magic wasn't magic at all. And then, sometime around the year 1800, it vanished. The techniques, the materials, the secret itself all lost to time. The greatest sword in history became a ghost, its formula a forgotten legend locked away in museum displays. The case went cold for nearly 200 years. The mystery, it turned out, wasn't the process, it was the ingredient. The secret of Damascus steel wasn't actually from Damascus. It was from 3,000 kilometers away. In India, they were called Wootz ingot, small, unassuming cakes of steel, shipped along ancient trade routes from India to the forges of Syria. This was a unique crucible steel, supersaturated with carbon up to 2%, far higher than European steel. But this steel had an impurity, a contaminant, traces of an element called vanadium. For decades, modern metallurgists tried and failed to reverse engineer the process. They had the recipe, but were missing a key ingredient they didn't even know existed. Finally, in 1998, metallurgists John Verhoeven and Alfred Pendray cracked the first part of the code. They found that the trace amounts of vanadium in the Wootz steel acted as a microscopic highway, guiding carbon atoms to align into specific structures during the forging process. But this only happened within a tiny, perfect temperature window, right around 850 degrees Celsius. Too hot, and the structures would dissolve. Too cold, and they wouldn't form. The ancient smiths, working without thermometers, had mastered this by eye. But even Verhoeven and Pendray couldn't fully explain the steel's almost supernatural strength and flexibility. The real smoking gun wasn't found until 2006 by a team of researchers in Dresden, Germany. They took a fragment of a 17th century Damascus blade and placed it under a high-powered scanning electron microscope. When they zoomed in 50,000 times, they found this carbon nanotubes, one of the strongest materials known to modern science. Structures so small and so perfectly formed, we only officially discovered them in 1991. But they were existing, locked inside this sword, for over 1,000 years. The microscopic nanotubes were reinforcing the steel from within, creating a composite material centuries ahead of its time. The legendary patterns on the blade's surface weren't just decorative, they were the visible, macro-scale evidence of this invisible nanoscale architecture. This is not magic. This is accidental nanotechnology. The ancient smiths of Damascus were not sorcerers. They were masters of process. They were scientists of the forge, observing and refining their craft over generations. They didn't know why the Indian Wootz steel, and only that specific steel, worked. They just knew that it worked. They didn't know what a carbon nanotube was or what vanadium did. They just knew the precise cherry red color the steel had to be when it left the fire. They knew the precise rhythm of the hammer blows to shape it without shattering it, and they knew the precise moment to quench it, locking that structure in place forever. So why did the secret vanish? Because the specific mines in India, the ones containing or with that perfect contamination of vanadium, ran dry. The source of the unique raw material disappeared. Without the crucial, invisible ingredient, the recipe no longer worked. Soon, the Industrial Revolution arrived. Mass-produced steel cheap uniform and reliable replaced master-crafted steel. The world changed. The secret wasn't a lost spell. It was a lost material, and a lost patience for a craft that took a lifetime to master. We didn't lose the magic. We just stopped practicing the craft. If you found this story as fascinating as we did, be sure to like this video, leave a comment with your thoughts, and subscribe for more deep dives into the hidden history of our world. Thanks for watching.